Today's learning goal is to factor trinomials. Factor trinomials. So here we have example 19, where our goal is to factor 16w squared plus 118w minus 15, and then we're going to check by substitution. So first off, we're going to put our 16w squared and our negative 15 inside our area model, and you should know that our two linear terms are going to multiply to 16w squared times negative 15 is equal to negative 240w squared. Or in prime factorization, we have negative 2 times 2 times 2 times 2 times 3 times 5w squared. And you should also know that our two linear terms that are missing here are going to add to 118w. So let's go ahead and look for pairs of numbers that fit these criteria. So you should also know that because they multiply to a negative number and add to a positive number, that one of the linear terms is going to be positive and the other one is going to be negative, and the positive one will have a larger magnitude. So our first pair here is going to be, let's say, negative 1w and 240w, or 2 times 2 times 2 times 2 times 3 times 5w, and these are just going to add to 239w. And you'll notice that in this lesson I am adding as we go and find the terms, so that in case we find it early, we don't have to waste time finding 10 other terms that are also not working. So our next pair that we're going to try, because 239w is not what we are looking for, is going to be negative 2w and 120w, or in prime factorization, 2 times 2 times 2 times 3 times 5w. So these two numbers are going to add to 118w, which is exactly what we were looking for. So we can go ahead and put them inside our area model. So we're going to put the 120w here and our negative 2w here. And then now, in order to successfully factor, we have to look for greatest common factors. So then first off, I'm just going to look at this bottom row here. And at first glance, these may seem to be relatively prime, but we can actually factor out a negative 1 here. And just for future reference, negative 2w is equal to negative 1 times 2w, and negative 15 is equal to negative 1 times 15. And because this is negative 1 times 2w, and we have the negative 1 here, we have to put the 2w at the top in order for these to multiply to negative 2w. And similarly, we have to put a 15 at the top right in order to make sure that we have a negative 15 in the bottom right. And so 16w squared is equal to 2w times 8w. So we are justified in putting our 8w on the left. And to make sure the last piece fits, 8w times 15 is equal to 120w, which means that our answer is going to be 2w plus 15 times 8w minus 1. And to check our work, we're going to substitute in w equals 1 into both our factored expression and our original expression. So starting with our factored expression, 2w15 times 8w minus 1 for w is equal to 1 is going to equal to 17 times 7, which is equal to 119. And then for our original expression, 16w squared plus 118w minus 15 for w is equal to 1 is going to equal to 16 minus 15 is 1, plus 118 is 119. So because we have checked our work for w equals 1, we can be reasonably sure that our answer of 2w plus 15 times 8w minus 1 is correct. Now go ahead and pause the video and discuss with your neighbor what happened in this example. So here are two for you to try. Factor each trinomial and then check by substitution. In part A, we have 4p squared minus 17p plus 4. And to factor it, you're going to have to fill out the area model and look for pairs in the multiply to and add to boxes. And similarly, for part B, 6y squared plus 5y minus 6, you'll have to fill out the area model and complete the multiply to and add to boxes. Now go ahead and pause the video and try these two on your own with your neighbor. See how you did. So in the area model, I completed negative 16p and negative 1p because I knew that they had to multiply to 16p squared and add to negative 17p, which means that they both had to be negative numbers. And the first pair I tried was negative 16p and negative 1p, and these added to our negative 17p, so I knew that they were going to be our answers in the area model. So then, in the area model, I was able to factor out a negative 1 on the bottom, because negative 1p is equal to negative 1 times p, and 4 can be negative 1 times negative 4, which means that I can put a p at the top here, and a negative 4 here. And lastly, 4p squared divided by 1p is equal to 4p, and to make sure everything works, 4p times negative 4 is negative 16p. So our pair is going to be 1p minus 4 and 4p minus 1. So then that gives us our answer here. And to check our work, I substituted in 1 for our expression here. 1 minus 4 is negative 3, 4 minus 1 is 3, and those multiply to negative 9. And for the quadratic, 4 minus 17 plus 4 is equal to negative 9. So for example B, after filling in the 6y squared and the negative 6 in the area model, I knew that they had to multiply to negative 36y squared, and the linear terms had to add to 5y. So then I tested many pairs, and because they multiply to a negative number and add to a positive number, the two linear terms are going to be one negative number and one positive number, with the positive number being larger in magnitude. So then I tried many pairs here, and then going through, I came across 5y, and then 5y coming from negative 4y and 9y as pairs. So then I plugged them into our area model, and then I factored out a negative 2 on the bottom because negative 4y can be represented as negative 2 times 2y, and negative 6 can be represented as negative 2 times 3, which lets me put a 2y at the top here and a 3 at the top right. And then 6y squared is 2y times 3y, and 9y is 3 times 3y. So our pair is going to be 2y plus 3 times 3y minus 2. So then to check our work, I substituted in 1 for our expression, and 2 plus 3 is 1, or 2 plus 3 is 5 rather, and 3 minus 2 is 1, and 5 times 1 is 5. And then for our quadratic, 6 plus 5 minus 6 is also 5. So we can be reasonably sure that our factored expression is correct. So here are two more examples. Use your results from example 20 to factor each trinomial and check by substitution. I'm going to walk through part A for you, and then you can try part B on your own. So for part A, you'll notice that 4p to the 18th minus 17p to the 9th plus 4 is essentially the same form as 4p squared minus 17 plus 4, except that the exponents have changed, as I said. So basically, because p to the 18th is equal to p to the 9th squared, we can almost do exactly what we did in the past, where I can just put negative 1 times maybe p to the 9th here, and then here I can put negative 16 times p to the 9th, and you'll notice that our linear terms still multiply to 16p to the 18th, just as our constant in our larger exponent multiply to 16p to the 18th. So then, to factor, we can just factor out a negative 4 here at the top, and a negative 1 here, because 4 can be represented as negative 1 times negative 4. And negative 1 times p to the 9th divided by negative 1 is just going to be p to the 9th. And what's remaining is just going to be 4p to the 9th. So then all of our factors, I guess, multiply to what we need inside the area model. So then our answer is just going to be p to the 9th minus 4 times 4p to the 9th minus 1. And to check our work, we're still going to use 1 here because if we use 2, 2 to the 18th is very large. So 1 minus 4 is still negative 3, because 1 to the 9th is still 1. And 4 minus 1 is 3, so negative 3 times 3 is equal to negative 9. And the same thing at the top, 4 minus 17 plus 4 is also equal to negative 9. So we can be reasonably sure that our factoring is correct here. So go ahead and try part B on your own. We have 6y to the 14th plus 5y to the 7th minus 6. And if it helps, you can refer to our previous example. So let's see how you did on this example. So I simply just pretty much copied our previous example in example 20, except instead of y squared, I used y to the 14th. And instead of y, I used y to the 7th. So then our pair was still the same as the one we had found. And so now our two factors are going to be 2y to the 7th plus 3 and 3y to the 7th minus 2. And to check our work, we substituted in 1 for y. So 5 times 1 is equal to 5. And 6 plus 5 minus 6 is also equal to 5. So these large trinomials may look easy, but what we're doing here only works when the smaller exponent or smaller y exponent is exactly one half of the larger y exponent in the trinomial, or a 1 to 2 ratio. And if y to the 7th were not 1/2 of 14, then we would not have been able to do such an easy process. Now go ahead and pause the video and discuss what happened here with your neighbor. So here's another one for you to try. In example 22, complete the following factoring problems. How do these problems compare? So we have 8m squared and 48 inside the area model here for the trinomial 8m squared plus 40m plus 48. And you'll notice that we already kindly completed your multiplication table here. And for part B, we have 8 times the quantity m squared plus 5m plus 6. And you're also going to factor these and fill in the area model. Now go ahead and pause the video and try these on your own or with your neighbor. Let's see how you did. So I filled in the area model here because looking through our addition or multiplication table here, 24 and 16 add to 40m, which is what we were looking for. So I put the 24m here and the 16m in the top right. So then I was able to factor out a 24 on the bottom because 24 times 1m is equal to 24m, and 24 times 2 is 48. So I put 1m at the top and then 2 in the top right. So then 8m was our last remaining piece because 8m times m is 8m squared and 8m times 2 is 16m. So then when I actually factored it, I had 8m plus 24 times the quantity m plus 2 is equal to 8m squared plus 40m plus 48. But I noticed that 8m plus 24 was not yet completely reduced, which means that our final answer is actually 8 times the quantity m plus 3 times m plus 2. And for part B, this is actually the same question as part A, except that instead of having to factor out the 8 at the end, we factored out the 8 in the beginning. And you'll notice that our multiplication table was much shorter than in part A. So then here we notice that 2m plus 3m is equal to 5m. So I placed 2m and 3m inside our table here, and I got m plus 2 and m plus 3 as our factors, with the 8 already factored out from the beginning. So go ahead and pause the video and check how you did with your neighbor. In this next example, note that before using the area model, be sure to factor out any common factor. So in example 23 here, we have to factor negative 16x squared minus 60x plus 100, and then check by substitution. And I'm sure you've noticed that negative 16 and 100 multiply to negative 1600, which is very large and has a massive amount of factors. So we're going to start off factoring out some constants. So at first I noticed that 16, 60, and 100 are all divisible by 2, and they're all negative. So I'm going to factor out a negative 2 first, which gives us negative 2 times the quantity 8x plus 30, or 8x squared plus 30x minus 50. And then I also noticed that 8, 30, and 50 are still divisible by 2, so I can factor out another 2 to get to negative 4 times the quantity 4x squared plus 15x minus 25. And this is the greatest constant that we can factor out because 4 and 15 are relatively prime. So go ahead and try the rest of the problem on your own after I've already factored out this constant for you. And I'll go ahead and pause the video, and I'll come back to you in a couple minutes to check your work. So let's see how you did. First off, I noticed that our two numbers had to multiply to negative 100x squared, and our two linear terms had to add to 15x because of the form of our polynomial. So then I hunted down pairs until I got to negative 5x and 20x as our two linear terms because they add to 15x and multiply to negative 100x squared. So I placed them inside our area model, and I noticed that negative 5x can be represented as negative 5 times x, and negative 25 can be represented as negative 5 times 5. So I put a negative 5 here on the left, which let me put an x at the top and a 5 in the top right, and the last remaining piece was a 4x on the top left, because 4x times x is 4x squared, and 4x times 5 is 20x, which means that our final factored form is going to be negative 4 times x plus 5 times 4x minus 5. So to check our work, I substituted in 1 again, so negative 4 times 6 times negative 1 gives positive 24, and negative 4 times 4 plus 15 is 19 minus 25 is negative 6 is 24. So because it worked for x equals 1, we can be reasonably sure that our answer is correct. So here's a similar one for you to try. In example 24, factor negative 9m squared minus 66m minus 21 and check by substitution. Now go ahead and pause this video and try this one on your own, and I'll come back in a couple minutes to check your work. So let's see how you did. So I factored out a negative 3, and that gave me a factored polynomial of 3m squared plus 22m plus 7. So I placed my 3m squared in the top left and my 7 in the bottom right. And then I started hunting for pairs that multiplied to 21m squared and added to 22m. And the first one I tried 1m and 21m added to 22m, so it worked. So I placed my 1m in the top right, my 20m in the bottom left, and then I noticed that 21m can be represented as 7 times 3m, and 7 can be represented as 7 times 1. So I put a 7 on the left, which let me put a 3m at the top left, a 1 in the top right, and our last missing piece was an m here. And to check everything, 3m times m is 3m squared, and 1 times m is 1m. So then our final factored form is going to be negative 3 times 3m plus 1 times m plus 7. And to make sure that this factored form is the same as our original trinomial, negative 3 times 3 plus 1 is 4 times 1 plus 7 is 8 gives us negative 96, and negative 9 minus 66 minus 21 is equal to negative 96. So as we wrap up the lesson, remember that our learning goal was to factor trinomials. So here are some questions for you to answer. What is the first step of factoring? Why is this important to do first? How do you check that your factorization is probably correct? What would it mean if none of the linear pairs worked out in the area model?